Hello class, thank you for hanging out with Professor Choi again. Today we're going to be talking about Introduction to Probabilities again. This is video number 4, so if you're watching this video, remember there are a few other ones before this one. And what we're doing in this particular series is we're introducing you to the way we calculate probabilities in statistics classes. So we have another probability example here that we're going to be working out. Alright, now in this particular video, we're going to tackle this simple problem here, and then we're going to talk about what a permutation and a combination are, and then how to use a permutation and a combination in order for you to try to figure out a probability for something. So let's start with this simple video here. Alright, a simple example. Professor Choi has 6 shorts, 14 shirts, and 10 pairs of shoes. And the question is, how many different ways can he dress up? Now, the answer to how many different ways can he dress up is pretty simple. What you got to do is you got to take 6 multiplied times 14 multiplied times 10. So basically, if you have 6 ways of doing one thing, 14 ways of doing another thing, and 10 ways of doing another thing, and they're all combined, then you have 6 times 14 times 10 different ways of doing that. So we got 6 times 14 times 10, and that's 840 different ways that I could dress up. Now if you want to kind of like visualize what we're trying to say here, what we're saying is you have 6 shorts, 1, 2, 3, 4, 5, 6, then you have 14 shirts, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and you have 10 pairs of shoes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright? Now the first way you can dress up is by using this combination here, so that's combination 1. The second way you can get dressed up is by using that, and then this. The next way is that, and then this. The next way is that, and then this. The next way is that, and then that, and so on. And then you can jump into the second one, so you could do this, this, and the first, this, and the second, this, and that. And then a shortcut to how many ways you could do that is 840. Okay? Now, imagine that somebody asks you, what is the probability that you're going to pick a one combination, any particular combination of ways in which you can dress up? Well, the answer is 1 over 840, because one of the combinations is 1, and then the total amount of different ways in which you can get dressed up is 840. So the probability that you're going to pick any individual set of clothing, aka one shirt, and one pair of shoes, is 1 over 840. Alright, now let's work on how to use this to calculate probabilities. In the state of Florida, we play the lotto, and in the lottery there are all these different combinations of numbers that you can pick if you want to win. So let's come up with an example that is something like the lotto so we understand. Okay? So let's say that we're going to play the Ch5 3. And the way the Ch5 3 works is we're going to pick 3 different numbers. So pick number 1, 2, or 3. The number can be any number between 0 to 9. So which is the same thing as saying, by the way, number 1 to 10, because you like 0 to 9. Alright? So you got 10 different numbers. Okay? And you could put any of those numbers, and if you get the right combination, you're going to win. Alright? So basically I could use the number 001, but I could also use the number 002, and I could use the number 003, and I could use the number 004, and I could play the number 005, or I could play the number 105, or I could play the number 135. Alright? Now how many different combinations do you have? Well, we have 10 numbers that we can write here, 10 numbers that we can write here, and 10 numbers that we can write here. So 10 times 10 times 10 is the amount of times that this can be done. So we got 1,000 different ways in which you can do this. All all the way from 000 to 999. All right, now imagine that somebody asks you, let's say you buy one ticket. All right, so you buy one ticket and you play this. Then what is the probability that you're going to win? Well, the probability you're going to win is 1 over 1,000. And 1 over 1,000 is 0.001. That is your probability of winning. Now remember from the previous videos that we express probabilities in decimals, but if you want to tell people this probability in, if you want to tell it to them in percentages, then what you got to do is you got to move this couple of steps that way, and then the answer is 0.1%, because percent means per 100. So it's 0.1% or 0.001 is your probability of winning if you play this right here and you buy one ticket. Alright, with that in mind, let's talk about things that might be a little harder. Okay? So instead of you being able to just do this in a particular way, let's get a little bit more complex. So a permutation is any arrangements of R objects selected from n possible objects, and the order of objects is important, while a combination is any arrangements of R objects selected from n possible objects and the order of the objects is not important. Alright, now a permutation is something that you would use when somebody's saying, imagine that we have to select 5 people, but if you select the first one will be the president, second will be vice president, and third one will be something else. Alright, now to understand this, let's kind of use a basketball analogy. Okay, so let's say we have a basketball team. And we have 15 players on that team. Alright? Now let's say we need to select 5 of those players to play on the floor. Okay? And let's try to figure out how many different teams can you form depending on whether the order of the objects is important or the order of the objects is not important. Okay? So, in option A, when we select the player, the order of selection determines the position on the floor. So the position on court is determined by the moment in which you selected the player. So basically the first player that I picked will be, I don't know, forward. And then the second player that I pick will be defense and so on. Okay? So you put the positions on the floor will depend on when you pick the player. Now this example is what we call a permutation, because the order of the objects is important, and because you're picking each individual and then the order in which you pick them selects their position on the field. Alright, so the question is, how many different teams do we have? So how many teams can I form if that is the case? So how many teams do I have? Alright, now, in order to answer the question of how many teams do you have, since we know that the order of selection is important, then we're going to use our permutation formula. Now in this case, in order to use our permutation formula, we have to pick an n and an r. Now the n is the total amount of possible people, and in this case you have 15 different players. So our n is going to be 15, and we have to pick 5 of them, so that's going to be our r. Alright? Now this formula here reads n permutation r equals n factorial divided by n minus r factorial. So the way we write this is basically 15 P5, 15 factorial over 15 minus 5 factorial. Now, in case you forgot how to do factorial, basically this means that we have to do 15 times 14 times 13 times 12 times all the way to 2. You don't need to do 1 because times 1 stays the same. Alright? But we got to do 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times. That's what that means. And then in here we got to do 15 minus 5, which is 10. So we got to do 10 times 9 times 8 times 7 all the way to times 2. And then when you do that, you got your answer. Alright, now you could choose to do this, but you could also just find the place where that is in your calculator so you can do it. Alright, now in my particular calculator, and I have a TI-30X solar, which by the way is what I recommend to most people who have it. It's a very simple, pretty cheap calculator. Okay, I have a place where I can get that done, and let me put it closer to you real quick. So if I go over here where it says PRB, then I will find NPR and NCR and factorial. Okay, so in order to do the problem that we have right now, which is basically 15P5, okay, what I gotta do is I have to put the 15, then I gotta go to PRB, I select NPR, which is the one that we're doing, which is permutation, and then I put the R, which is 5, and then the answer will be 360, 360. So 15P5 is 360, 360. So we have 360 different ways in which we could do that. All right. Now, in a basketball team, sometimes that's true, by the way, but as you probably know, players kind of like, they can shift around. They have their I would say preferences. So, some players are better at particular things, some players are better at other, like if you're really tall, or big, you're normally center and stuff like that. Then the guys who handle the ball, again, are different and pass the ball and organize. So, a lot of the times, though, you're multiple things inside court. So imagine instead that your order in which you get selected does not determine your position on the field. Alright, so let's change the example a little bit, and let's say that when we select a player, the order of selection does not determine anything. So the order of selection does not determine anything. And then same question. How many teams do I have? Well, because the order of selection does not determine anything, in other words, the order of selection is not important, then the players can just flip around. Then the question is, how many teams do I have? But remember, each individual inside the 5 people that I pick on the team can move around. So they're not fixed in their position. So we're just asking ourselves the question of how many combinations of these can I have? Alright? So the answer to that is this right here. You got to do 15 C5 equal to n factorial, and our n is still going to be 15 because we still have 15 total players, divided by r factorial, that's 5 factorial, and then 15 minus r factorial. Alright? So again, our r is still 5. Now remember, if you want to do this, you have to set it up as 15 times 14 times 13 times 12 all the way to times 2 divided by 5 factorial. So you got to do 5 times 4 times 3 times 2, and then once you do that, you got to multiply it times 10 factorial, which is 10 times 9 times 8 all the way to times 2. Alright, and then you solve that. Now if you don't want to do that, you got to find where the shortcut is in your calculator. So let's do it on my calculator. Okay? Now again, on my calculator, you go to the PRB function. So what I got to do is I got to put the n first. So I put 15. And then after I put the 15, I do PRB. And then I move it to NCR. Click on enter. And then I put the R, which is 5. And then I click on enter. And then now I get the number 3003. Okay? So I have 3003 different ways in which I can have 5 players out of 15 players on the court. Okay? Alright. Now, whether you're using combination or permutation in order to find a probability depends on the specific problem that you're being given. So you need to figure out which of the two works better for the moment that you have or the question that you have. Alright? So let's come up with a different question. And since my students usually like the lotto, then let's again use a lottery example. Okay? So let's say to win the Ch5 lotto, you need to select 6 numbers correct, and you have 53 possible numbers to select. Now the order of the numbers doesn't matter. The order of selection does not matter. Because the numbers will be arranged from smallest to largest. Alright, so to win the Ch5 lotto, you need to select 6 numbers correct. You have 53 possible numbers to select. The order of selection doesn't matter because it's the numbers will be arranged from smallest to largest when you're done. Okay? So how many different ways can we select a number? Or how many different combinations do we have? Alright, now because the order of selection doesn't matter, this will be a combination. It will not be a permutation. It will be a combination. Alright? Now if the order of selection matter, remember, it means that you can pick the number 53, for example, on all 6 different ways. Okay? So you could put 53 on the first one, and 53 on the second one, 53 on the third one, and so on. Now in this case, the order doesn't matter. So what that means is that the numbers will be rearranged regardless of where you pick them. So all you got to do is pick one, and then if you get the right 6 numbers, it doesn't matter in what order you pick the right 6 numbers, then you win. Alright, so this is a combination example. Alright, so we set it up like this. We set it up as 53 C6. Okay? Now again, if you didn't get the shortcut on your calculator, you can just use that formula and it will take quite long, but let's do that shortcut again. So in my particular calculator, I have the PRB button. So I first have to give it the N, which in this case is 53. Then I click on PRB. Then I select NCR because I'm looking at a combination, click on enter, and then I gotta give it the R, which is 6. And then that's the answer to how many different combinations I could do this. Alright, so my answer is 22957,480. So there are 22,957,480 different ways in which I can do this. Alright, now imagine that you buy one ticket to the Choi Lotto. And somebody says, well, what is my probability of winning with that one ticket? Well, the answer is, your probability of winning is 1 over 22957,480. So your probability of winning is 1 divided by 22957,480, which is going to be 0.123456744. By the way, in case you live in the state of Florida, this is very similar to something that we play in the state of Florida. And your probability of winning, if you buy one ticket, it's that. Alright, now here's something you need to understand about probabilities and the difference between an individual probability and a group probability. Okay? Imagine that we have 22,957,480 tickets sold, and each individual bought one ticket. And each individual got a different number. And somebody asks you, what's the probability that one individual is going to win out of the whole group? And the probability is basically 100%. Someone's going to win if you sold 22,957,480,000 tickets and everybody got a different number. Okay? So someone's going to win. One person's going to win. But let's say that somebody asks you the question of, what is your probability of winning? As in like my ticket, my number. Then the answer is 0.00000044. Alright, well, I hope you liked my video today explaining lotteries and how they work. And by the way, that's why I don't play the lotto. I instead invest. Have a good one.